Hello and welcome to today's Vision Channel session. My name is Heiko Seitz, Product Marketing Manager at IDS, and I would like to introduce you the many practical enhancements for our UI Live monitoring cameras that you can also install on your cameras with the recently released and free firmware update 1.1, because this allows you to make process monitoring even more efficient and autonomous. If you are not yet familiar with the handling or the application fields of our monitoring cameras, I can also recommend our introducing how-to video with my colleague Rob Webb, which you can also find in our video library and watch on demand at any time. He shows, for example, how to set up the camera, an overview of the camera web front end, the web-based REST interface, and the programming example that sends a software trigger to start the recording. Let's take a closer look at the latest features. And if you have any questions during the session, please feel free to use the chat or the Q&A module of Zoom at any time. I will try to respond to all your questions after the presentation and try to answer them. The firmware 1.1 is a comprehensive feature update. It expands the camera's application options with many interesting improvements. Selectable overlays show important status information during the operation, and the internal device memory is now filled dynamically, depending on the size of the individual recordings instead of being divided into fixed time slots. An integrated FTP client enables the recordings to be saved automatically on an FTP server, and the recording events can now also be triggered by electrical signals, and for that, the I/O ports can now be coupled with internal camera functions such as the recording with an operation mode. Besides the house model variant, these monitoring cameras are now also available as small single board cameras, either with or without a lens mount for various standard lens sizes. In this way, the UI Live features can now also be seamlessly integrated in existing housings. As usual with our single board series, there is also a motherboard variant, which with its connections routed to a space-saving SIF connector. This means that they can easily be wired to connectors on the device housing using flex cables. The single board camera model is now also available in our webshop. But now let's take a closer look at the software extensions. And to do this, I open the web front end of my already running UI Live camera in a web browser. In the redesigned monitoring dialog, you can quickly identify the current streaming and recording configuration. So by copying a streaming URL, for example, you can quickly open a live view with the current streaming settings in a streaming client. I'll do this here with Stream 1 because we'll need this in a moment. Next, we jump to the new overlay feature in the camera configuration. Here you can insert various overlay elements at predefined positions in the video area. The live status already flashes at the top left. There is also the device location string, for example, which you can define for the camera itself. Or we can place a crosshair in the center of the screen. You can also load up to 4 of your own images onto the camera and use them. And to show this, I have loaded a robot icon here. Last but not least, we also have a timestamp, and we can even display the milliseconds here. This can be enormously helpful, especially when analyzing recordings. For example, if you want to identify the exact time of an event on time synchronized cameras. We can see this later in the use case. In the enable area, we can activate the configuration elements for stream 1 and 3. The overlays can be activated while the stream is running. So now stream 1 also shows the overlays. For event recording of stream data, there are also a few new improvements. Above all, the internal camera memory can now be used much more flexibly. The restrictions to a maximum number of files of recording is no longer existing. Instead, only the file size of the recordings now determines the maximum total recording time in the memory. This means that with smaller files, the more files can be stored in the memory and the longer you can record in it. The size of the video data and therefore the storage amount is of course dependent on the streaming parameters, resolution, frame rate, bitrate, the frequency of keyframes. Of course, the scene content is also crucial for the compression performance of the encoder. Here are a few examples that we have determined with tests to give you a rough idea. The encoder generates a video file of about 36 megabytes when recording 30 seconds of video at an average bitrate of 10,000 kilobytes per second at a frame rate of 30 frames per second. And this means that around 28 files can be stored in the memory, which corresponds to a total video time of approximately 40 minutes. In case the camera's internal recording memory of 1 gigabyte is too small for your application, which can easily happen if many events occur in a short time, there are two more features to solve this issue. With the override protection, you can now decide yourself whether new video recordings may override the oldest ones or not. In other words, the memory either continues to work in first in, first out mode, where newly created recordings replace the oldest data in the memory, or you can protect the memory data so that it is not overwritten or deleted. In this case, however, new events can no longer be saved. You must therefore ensure yourself that there is also always enough free memory available in the camera, for example by downloading the recordings from the camera promptly and releasing the onboard memory again, which you can do via the REST interface using software, for example. And this is exactly where the auto FTP upload comes into play. With firmware version 1.1, the camera gets an FTP client and can automatically save your recordings to a connected FTP server as soon as they arrive in the memory, and also automatically free up the memory. This means that the camera only uses the internal memory as a self-managed buffer that always has enough free memory. The new recording features are clearly arranged in the straightforward recording dialog and are therefore quick and easy to use. Last but not least, and in my opinion, the most important extension to turn the camera into an independent or PC-less process monitor or logger, the event triggering via the I/O ports of the camera. In other words, the electrical triggering. Before firmware 1.1, a PC with a camera-based application was needed in the monitoring process to record an event via a light beam sensor. For example, in order to start a recording with a software trigger in the camera after an electrical event and to copy the generated data. With firmware update 1.1, a host PC or external camera application is no longer necessary. You simply connect the signal or the signaling device, such as the light beam sensor or another trigger, to one of the GPIOs or digital input of the camera. The camera now automatically takes care of the recording and also transfers the data to a connected FTP server. Access to the web frontend is now only necessary for configuration. At runtime, the monitoring camera now works completely independent. The connection of incoming trigger signals to the recording function in the camera is created by a new operation mode, which you can configure separately for each of the IOs. With firmware 1.1, we start with the connection to event recording. With future firmware updates, further connections to internal camera functions can be added here. We have created this trigger use case here to show you how it works in operation. And with this Marvel track, I can trigger the camera via its GPIOs or the digital input, which then activate preset recordings in the camera. The light beam sensor of this Marvel track is connected to GPIO 1 of the camera via a standard I/O cable, and the manual button is also connected to the digital input. And in this case, I have coupled both IOs with the recording function via the function mode in the web front end of the camera. I can now trigger events via the button as well as via the light beam sensor with the marbles. Each new event re-triggers the camera and creates its own recording file. For the live test, I've entered a server connection in the camera's FTP configuration, which will be used to automatically save the recordings later. If everything is entered, you can then test the connection here. Okay, everything seems to be working. Then I can activate the automatic FTP transfer in the recording dialog. I'll simply test this here with a software trigger. The software trigger initiates an event, which is followed by a recording based on the previous settings, and then the files ends up in the FTP server folder. I place 3 marbles on the marble run quickly, one after the other. With each trigger of the light beam sensor, the camera saves an event on the FTP server, as we can see in the folder window below. Now let's take a closer look at these 3 recordings. So here are the 3 recordings. I configured a pre-alarm time of 3 seconds and a post-alarm time of 5 seconds for this use case. So recording 1 triggered by the first marble shows 3 seconds pre-alarm before the triggering. The post-alarm time is interrupted by the trigger of marble 2 after 3 seconds, and recording 2 is created. We will note the timestamp of marble 2. After the pre-alarm time, recording 2 shows the trigger time of the second marble at the same time stamp as recording 1. At the same time, this recording is also interrupted by the trigger of marble 3. And we also note this trigger time. And now, last one, recording 3 then shows the trigger time of marble 3 at the same time as recording 2. And then it records the full set 5 seconds post-alarm time till the end. With this recording behavior, a recording file is created with each trigger, even if events happen in close sequence. Even though the fast file changes result in shorter post-alarm times, no data is lost due to the overlapping time. This makes the UI Live cameras suitable also for monitoring very fast applications. The feature update 1.1 makes the IDS monitoring cameras a very efficient and autonomous solution for monitoring your processes and recording important events in order to use them possibly to analyze an error situation. If you would like to learn more about our monitoring cameras, please visit our website or contact our sales specialists at any time if you would like to talk about your processes or your use cases. Then I would say thank you very much for your interest to join our session, and as every time, also this video can be watched on demand in our Vision Channel media library.